So I think I win for the most gear on stage. I even have more props over here, so it's going to be kind of like a Gallagher show or something. All right, so my name is Kirk Membry. I'm a senior experience designer for MadPow. We're in Portsmouth, New Hampshire, and over in Boston. And today I'm going to talk about immersive UX, designing for virtual reality, best practices for virtual reality. So a little bit about myself. I have over 20 years experience as an IA UX designer. I worked at IBM in Burlington, Williston actually, about 20 years ago. I've also worked at Dell, Viacom, Panasonic, you name it. And I've been a panoramic photographer for about 10 to 12 years, shooting 360-degree panoramic photos as well as 360 video. The picture of me up there, that's at the top of Mount Washington. If any of you, who's been up there? Anybody? Awesome, wow. So they redid the museum a few years ago, and they hired me to shoot big panoramic. It's on the 3 monitors there. So I had to go up in the winter in the snowcat and then go back up in the fall to shoot that. So now you know who did those pictures if you saw them. So what is VR? Virtual reality is an immersive environment, and for what we're going to be talking about, it's mostly just visual. A real environment could have, like, you could feel tactile stuff, touch and everything, haptic feedback type things. That's coming, but it's not quite there yet. I will touch on that a little bit. But for the most part, VR, the way we think about it, it's devices like these little headsets. There's also a thing called augmented reality, which is a mixed media where you have an overlay on like a transparent screen, and you can bring graphics and different things like that. Microsoft uses the HoloLens as one of the early technologies of that. You've also got the Pokemon Go is kind of augmented reality, but not really, because there's no perspective mapping in it. It's just overlaying. You could hold it in the sky and it still has a shadow and it's on the ground. That will all change in the next year or so with Project Tango and the new iPhone 8 when all the extra lenses come in. But we're not talking about augmented reality. We're staying on virtual. So virtual reality got its start way back when, in the 1800s, with the good old perfectoscope or something like that. You've probably all seen those somewhere in an antique store with the little 3D postcards. Each picture is slightly different. That's called parallax. That's the difference between the 2 images. And when you look through the viewfinder, your brain combines those 2 images and it becomes stereo vision, or 3D. So this piece right here is a little divider that keeps one eye from seeing the other picture. And it's interesting because even in the modern VR headsets, it kind of has the same thing. You try to keep your eyes separate so that you can push 2 different images to your brain. So the perfectoscope, they did that in the 1800s. It was super popular. Fast forward to 1939, the Viewmaster was invented. Go into the 50s and 60s, they started licensing content from Disney. People started using them. They're super popular. They're still really cool. Then we get to, well, in the 1960s, you had a lot of colleges and military started working with virtual reality, more of what we know, hooking it up to a computer. In 1995, the VFX1 from Forte came out. That's this big, mega heavy thing. It weighed a ton. I got to use one back in the day. I worked for a video game company, and we got to test one out. It was horrible. It was really bad. It was so bulky, you felt like your head's going to fall over like a bobblehead. And the resolution was bad. The latency was really high. Latency is the delay. If the system can't process fast enough, you turn your head and then everything moves. If the latency becomes too high, the disconnect between your brain and the item that you're watching causes basically motion sickness. At the same time, in '95, you also had the Nintendo Virtual Boy. Anybody remember that? That was another horrible one, and it failed. It had a red screen, so it was 2 colors, black and red. Had a little controller. It was never meant to be a real product. Somebody created it in a lab, and then I guess somebody walked by, poked their head and said, let's make that. So they made it. It sucked. It went off the market. VR kind of fell away again. Fast forward again to 2014, and now we have the modern ones that we know. We've got the Oculus Rift, which tethers to a PC, and now, as of last week, a Macintosh. We have the Google Cardboard, which is right here. This is basically the modern version of the old perfectscope. It's got the divider between 2 lenses. You put your smartphone in, fold it up, hold it up. Oh, it's upside down. And you can view stuff there. There's also the PlayStation VR, hooks up to the PS4. and the HTC Vive, which is very much in competition with the Oculus. All of these dots on here are infrared LEDs, and that helps with motion tracking. I'll explain that in a little bit as well. Microsoft has the mixed media stuff coming out soon, which will be a much more inexpensive version of these types of headsets, probably in the $300 range. They'll be out for Christmas, so start getting your name on the list now. Besides having the headset, you can also hook up hand controllers. So right here I have the Oculus Touch. These have multiple IR sensors all around the edge that an infrared camera or 2 infrared cameras can see. And as I move around, it can track those positions in space. The headset itself also has them across the front. There's lights all in here and down on the sides. So, and actually you can see it in this photo. This must have been a prototype. You can see all the dots on there. So that's how it's measuring where your arms are, but it requires external sensors, sometimes called lighthouse sensors, in order to do that. The new Microsoft stuff has sensors in the band that can point cloud map the room. So you put it on, it can see, it figures out where you are, and then you can just move around. So that's going to be a huge advancement because it's going to start to reduce the number of wires and things, and I believe it's also going to be wireless. So, while you're really here, the 10 rules for VR. Now that we know what the devices are, we're going to have to create some experiences for them. And these rules are not the only rules. These are kind of like guidelines. I'm just trying to help you guys come up with something better. We've seen so much junk come out when like an iPhone came out, smartphones came out. There were all these crappy apps right off the bat. They slowly got better. VR is in that same thing yet again for what, round 2, round 3, maybe more, round 50. So the idea is like me being a UX designer and somebody who loves technology, virtual reality, 360s, all that stuff. I wanted to put it all together and just come up with a better interface. You know, try to, not so much the interface, but how all the interactions happen. So when you're interfacing with something, it's not just visual. It can be audio. There we go. It can be audio, video. In audio, you can speak to it. You can hear stuff back. Video, you can see things. You might have a camera input. Motion would be any kind of thing like a Microsoft Kinect or Elite Motion where you can move your hands. It can sense what you're doing. So you could do gesture controls, very much like Minority Report. You also have touch controllers, so any kind of game controller, sliders, touchpads, all of that stuff, those are good for interactions. And then you have haptics, which is the vibrations to make it feel like you're actually pressing a button. It doesn't always have to be vibration. They're doing stuff with air, kind of like ultrasound type things, air bladders, all sorts of different things like that. That stuff will be coming out down the road. And what that will do is you'll be able to put these gloves on, see an object in space wearing your headset, grab it and actually feel some weight to it and feel, not really weight, but you'll feel it like you can squeeze onto that glass or something that's floating in space. So the first thing is the easy exit. My father, when I was learning how to drive, my father showed me first how to stop the car, put it in park, turn off the key, or put on the handbrake and then turn off the key. He said, you need to learn how to stop this thing before I teach you how to start it. So I think that's a great place to start for VR advice. If we get into a bad situation in VR, we should be able to get out of that experience and not freak out. If the user gets disoriented, they're going to freak out. You can't turn your head away. As soon as you turn your head, you're still in that world. You know, it's not like you're watching a TV screen. If I'm watching the screen, I can turn away. With VR, as I turn away, I'm still in the moment. So if I'm into some horror game, I'm playing Doom or something, it's still going to be there. And then you add 3D spatial audio. So I'm going to feel things crawling up and around my body. So even if I close my eyes, I'm still partially in that environment. Or you can be like this woman and throw it off. There goes $700 worth of gear. We don't want that. So the Oculus, I'm going to use them for an example because that's the device that I've been using for a while. What they've done is they've added this Oculus button here, and they've tried to always set it up and map it in their games and other applications. When you hit that, it takes you back to a neutral home screen. Something very calming that's outside of the experience. You're still in a virtual environment. You're still wearing the headset, and this is what it would look like. It's just very plain, no motion. It allows you to go home. You can go back into the application that you were running. You can adjust volume, and you can do some other things in there. That's your emergency button. That's your panic button. It comes back into that experience, gives you a moment to breathe. You either leave, go back into Windows or whatever, or you can go right back into the app. If you hit the home button, this is the environment that you brought into. This is your Oculus Home. So this environment is where you would interact and play with all your games. Again, it's still pretty calming, but there's just a lot more going on. You know, you compare back to this, not much happening there, to this. So when you're in a game and something happens, it's nice that you can just come to this like neutral pause, figure out what you're doing. Next thing is to recenter the view. When you're playing a game or you're doing something, you have a headset on, you're walking around, you're doing whatever with it. Actually, it was this way. And I have all the wires and everything when I'm using an Oculus. I can get twisted around or I can step outside of the range of those sensors. Well, sometimes it doesn't always pick back up where you were. So I'm at my computer. This is kind of my neutral. This is my home. I'm looking around. I'm doing my thing. If I get mixed up or twisted, suddenly this is now home, and this is to my left. So what they've done is they've mapped the hamburger button, and it varies in different games, but when you're designing for different interfaces, always try to make sure you have a button not only to exit back to that menu, to the neutral menu, but to recenter yourself. So I'm facing this way, and I kind of take it off. I'm like, oh, wait, I'm not facing the right way. Go back here, hit the button, and the whole screen will jump, and I'll be locked back at my neutral position again, facing forward. And that's going to just help me not get all tangled up in my wires. Next thing is a neutral plane menu. What I mean by that is when you're in an environment and you're looking through a device, you can have your menus out in front of you. What we're showing here, this is actually this is a ViewMaster for a smartphone. It's kind of amazing that it took them a while to make this because this would have been the next evolution from the old reels. So here they have the people sitting down looking at stuff. This is what the environment would look like. You're looking at a QR code type thing, so you're seeing some augmented reality inside here. When you're in the interface and you're looking around, you're looking at, I don't know what it is, one of the London Bridge probably. If you want to exit out of that menu, the way they have it designed, you have to look at the floor in order to access this menu. That's not a very good experience. In a 360 environment, it's 360 around and it's 180 degrees, right, from top to bottom. I mean, if you go all around, it's 360, but it's 180 to the bottom. The top is called the zenith, and the bottom is called the nadir, or nadir. This menu is on the nadir, so I have to look directly down. Now, with this, it's not so bad because I'm just holding it. But when I wear the Oculus, I'm completely immersed. I'm not holding it with my hands or anything. I can't really lift it up. If I bend over, I could get disoriented and I can fall. This is actually the reason that I decided to do this talk, because I was using these different things. I'm like, these experiences are horrible. Like, they can fix this. So the way that I would take care of it is instead of having a menu down here on the floor, I would have an action point somewhere lower on the screen that would bring a menu up like this. Well, this is just an information thing, but you could have a menu. So while I'm looking at it, I just have to look down just slightly, just to get down out of the plane, out of the horizontal plane, activate my menu, and I want that to come up and float in front of me. That's going to be a much better experience. I don't want to go look at the ceiling and do that. I don't want to look at the floor. I also don't want to have to turn around behind me to access the menu. Whichever way I'm facing, I should expect that that menu will open in my direction. Even if I'm playing a game and all the action is here and I happen to turn around, when I hit the menu button, this is where my menu should live. The way menus come up, they can float in the environment, so they can kind of be pinned to the wall, and as you rotate around, that menu could float around with you. Or it can just float in space, or it can be pinned to the display that you're wearing. Think about the watermark in the corner of the TV. It's always there. If you had a camera going, you had that watermark, and you pan that camera, it's always going to live there. I don't see too many people doing that where they keep the menu kind of pinned to the environment. So even if I roll my head, that menu would always stay level. Even when I turn my head, to my eyes it's level, but the horizon would change. I think those type of menus could be the most useful, but you've got to figure out where they're going to go when they disappear, when you call them away. Next step would be large typography. I think that's pretty big. Current displays don't have that great a pixel density at this point. They are getting better. The Oculus right now is 2560 by 1440. So inside this display is an LCD monitor. So think of a tablet or a smartphone mounted in here. Those are getting better every day. There's a new 8K display that I think Samsung is going to start licensing, but we'll see when that comes out and how much that'll be. So you want to use larger typography for reading because you can get a thing called the screen door effect. When you're looking through the display, it's magnifying the pixels. And you can see here, this is the old Oculus DK2, Development Kit 2. You see all these lines? That's amplifying all of the pixels, so it looks like you're looking through a screen door. This was only 1960 by 1080 per eye. The new CV1, the consumer version that I have, they increased it tremendously. So this was a 1920 by 1080 display, and this is a 2560 by 1200 display, because you're splitting half of each screen. So because of that, you can actually read that same text that wasn't readable before is now readable. To get around that issue, I don't think in this one they should have left it like that. They should have increased the size of the font or done something with the scale between that information and where the viewer is watching it. Once they got a higher resolution, they can refine back and change up their design a little bit. So those are the basic interface rules. Now we'll get into the scene rules. Continuing on, we have camera movement should follow the user. Here's a game called Lucky's Tale, and you're running along. It's kind of like a 3D, like a Nintendo type thing. You're running along with your character, and you can jump and all that. You'll notice the motion that we're doing is going kind of up to the right, and the camera is following behind, you know, not directly behind, but off to the side, but you understand what's going on. You've played a million games like this. In real life, you're running around, you're riding your bike, you're used to everything coming towards you and past you. But the issue is, if you've ever ridden on a train and ridden backwards on a train in one of those seats that's flipped the wrong way, after a while, you start getting sick from it, because your brain is not used to tracking and having things go the other way. Like everything in our life is always coming towards us. So what happens in Lucky's Tale is there are a few instances after you're running forward, the camera moves out to the side and pivots around. As soon as it does that, you get this weird sensation in your stomach because the whole environment, as you roll your head and do everything, it reacts exactly to what you're doing. When they pull the camera away, the first time I did it, I grabbed my desk. I thought my chair was rolling backwards across the room. I reached down, I'm like, oh, I didn't move. But in my head, I thought I was like rolling back or falling backwards, and it was pretty horrible. So what you can do here is try not to do that whenever possible. I played the new version of Lucky's Tale the other night, and I didn't notice that anymore. So I think that they did remove that, and they try to keep the camera following around. Or if you do have to bring the camera around, maybe you initiate it sooner and just move it at smaller increments along the way. But to just kind of pull and move back, it doesn't work. So I guess they've taken feedback from people and they've added that in, which is great. Which gets to the next step. Don't force the viewer's direction. Do not force the viewer's direction, ever. The reason I say that is when you're wearing the headset, everything you do, I look around, I'm in this room, let's say this is a virtual room. I'm looking around, I'm looking at all of the walls. If you want me to look to the left and you move the room to the right, so now I'm looking to the left, but I didn't move my head, it's gonna feel like this whole room just spun around on me. That's what you do not want to do. You do that, you'll never have customers again. So do not do that. You also want to avoid extreme close-ups. You have the parallax effect between your eyes as one eye can see a little bit different from the other. In this example, there's a tree here, and you can see that the antenna is kind of up to the right edge of the tree, and over here the antenna is right under the middle of the tree. That's the slight difference on those two renders so that your eyes perceive that as 3D. When you bring things closer to you, the parallax starts to increase. That spacing increases because the angle of your eyes is changing. And a great example, here we can be interactive. Everybody put their hand out in front, look at your finger, and kind of wink back and forth with each eye. You notice your finger's pretty much in the same position. Now as you're doing that, draw it closer to your face. You'll notice it starts jumping further and further because it's going wider because the angle is changing. At a certain point, you can't even focus on it, and you end up with like two fingers, kind of, sort of, when you stare, like those old 3D dot puzzle poster things. So you get that effect going on. When you have an extreme close-up, everything breaks. So if you're looking at like a blood vessel or a white blood cell floating in space and it gets really close into your face, you try to pull back, but because you're wearing the headset, you can't actually pull back. You know, it's going to go with you. And if you have any kind of menus or anything that's key to your design, it should not be that close. It should be at a decent range. What that range is, I don't know. Just try it. Figure out what that is. It depends on what you're trying to do with it. I'm going to keep the world scale 1-to-1 with the viewer. When you're building out your worlds, when they're 3D, you can change that scale to anything you want. When I was shooting 360 panoramic video, or sorry, stills, I was doing real estate shots, so I was in houses taking pictures. I'm 6 feet tall, so I set my camera on the tripod, had the camera lens at my eye height, whatever that would be, just a little under 6 feet. I thought it was fine. I'm like, yeah, that's how I see the room. Shot everything, stitched it, put it up into a web page. It felt like I was up near the ceiling. It was so weird, that, and I'm like, but I don't notice that myself when I'm standing here doing it. But what happened is that height is not really correct in how you're doing stuff. And I found that if you went halfway between the floor and the ceiling, maybe a little bit higher than that, so probably like a 5-foot height, it tends to feel a lot better. Now, if you're in a huge room, obviously you're not going to put it up at 12 feet in here or whatever to be halfway, but you want it to feel a bit correct. Now, because it's not at halfway, I feel very small in this room. When people shoot 360 video, I've seen them do stuff where everybody's sitting around a table having dinner and they set up the gear so they can shoot 360. Afterwards, when you play it back, it looks like giant people kind of reaching for food and you're Ant-Man on the table, kind of like being in this room. You know, it's so huge and you're so small. It's really hard to fix that. I think it has to do with the lenses and the distance that you're putting it from objects, and if you're that close at a table, everything's in real close. So there's not much you can do there, but it is weird. You can either feel really large or really small, depending on how that works out. Trying to stay 1-to-1 is going to help. Now, when you're in a 3D environment, you can adjust that scale no problem. The Oculus, when you set it up, it wants to know how tall you are, because you're the default user. So you put in your height, and it's probably calculating down a couple inches to where your eyes would be. It also wants you to put the system on the table and then measure the height of that table from the floor to that table. So now it's kind of getting a scale of where it is. These sensors, you don't have to measure where they are, but it can figure out through triangulation and some of those other mathematical magic, because computers are good at math, as we learned earlier. You can, once you do all of that, it knows where it is. I can put these handsets down on the table. It'll see them. When I reach out in a virtual environment to grab it, it's in that spot. I'm touching it now. If that scale is wrong, it's either out here, now it feels weird because my hand is past where the item is, or it's too close, or I punch into a table because things are wrong. So that scale is important. If I kneel down in a game or in some kind of environment, I'm wearing everything, and I just kneel down, when my knee hits the ground in the virtual environment, my knee should be hitting the ground. If it's even an inch lower or a quarter inch lower, it's going to feel weird. And people can also get hurt from that. Next thing is to avoid critical interaction from occurring behind the viewer. It's not going to totally ever not happen. If you're playing a video game, stuff's going to happen behind you. But if you're storytelling, and a video game can be a story, you want to try to keep most of that action in your field of view. So if stuff is coming at you, you're doing your thing. Things are coming in from the sides, that's fine. Stuff is happening behind me, that's primary. I have to constantly look behind me to see what's going on. And that's the thing that makes me wonder when everybody says, oh, 360 video is going to be the future of cinema. Do you all want to turn around 180 degrees right now to continue watching the movie? You know, it's all happening here, and then they're saying it's going to be behind you. Plus, I don't know where all the crew is going to be when they're shooting that, because you're going to look behind you and just see guys with like cables walking down the path. So I've seen some people do stuff where they only show about 180 degree view and they don't worry about the back, because they figure that gives you, humans can see about 180, and then you go a little bit further. That's where most of your action is. So let's say in a game, something's happening back here. I can just have a voiceover, you know, like another character is like, look out, he's coming up on your left. So I gave an audio clue that something is coming up on the side. I could also have something flash on the side. Let's say it's a hallway, there's like an explosion, and I see light kind of come up from the side. It's like, oh, what was that? And it draws me over to turn to look. Now I can see the action that I want the user to look at on this side. I can also use spatial sound. I hear bugs crawling up a wall behind me. They're over here, and as I turn, I hear it come across. Now I know they're behind me and they're moving around. So you want to use all of that stuff in your environment to kind of coax the person into looking. Don't just pop up a menu or have the primary action, the guy that you have to talk to in the game. I keep saying games, but it can be whatever experience. Don't have that happen behind and just expect the user to know, oh, I should be talking to this person over here. The last rule is to avoid complex scenes if your target hardware can't keep up. The wow factor is lost, and the low frame rates, as I said earlier, the latency will cause problems. If you have this really complex thing, like I'm going to show you an example of Google Earth, if my machine couldn't keep up, there'd be no point watching it. It would just be frame by frame. It would look horrible. So those are overall 10 rules or advice. For the first four are the interface, and then the last ones are for the scenes. These will definitely help as you start to build out new experiences. So now on to the next fun part, avoiding the VR sickness. Who here has tried a virtual reality system? Awesome. Who's gotten, I don't want to say sick, but just kind of ill or dizzy or motion sickness? Looks like about a third. That's a huge amount, you know? You expect like people get food poisoning, it's like 1 in a million or something, but here it's like one third of the people get sick using the experience. They're part of your target audience. People want to use something, you have to acknowledge that people can get sick from the device that you're designing for. And I feel that you can treat that almost as if it's like web accessibility. You know, you try to have captioning and other stuff, and captioning should be done in VR. That's a whole nother talk, maybe for next year. But when you're thinking about your designs, if people are getting sick, how can you stop that? And having ways to exit out, okay, that stops it if it does happen, but how do you prevent it from even starting? So one way is to reduce the field of view. Like I said before, humans have roughly a 180-degree field of view. Most of the VR headsets are about 110 degrees. The inexpensive cardboards are about 90 degrees. You see black on either side when you're looking through the headset. The Star VR, this is one of the nicest ones out there. I haven't tried this yet, but I've heard it's pretty amazing. It's got 2 4K screens in it, one for each eye. It can do, what's that, 4096 would be 4K, but we know it's a little bit less than that. So they have a newer one that can do even higher. Putting in some of those newer screens, it's going to push it even higher. That gives you a 210 degree field of view when you're wearing that. So even action that's outside of your view coming in, it's just going to feel even more realistic. And speaking of hardware for that, this whole thing, if it's running 2 4K screens, you're going to need a beefy computer for it. So you're not going to see that as just a standalone headset anytime soon. So with the reduced field of view, you can reduce motion sickness. Google Earth introduced this. So what they've done here is you can see the whole world, but then when you move, you get into the smaller thing. Is Adam in here? Yep, Adam tried it at lunch. And how did you feel when it was in a smaller view? There you go. Now, when I turned it off, when I turned the comfort mode off so that the full width of the interface was shown, or the full width of the field of view, how did that feel? Yeah. But you get like a little bit, I found when I was using it, when I was standing there wearing it, and I turned off comfort mode, my body was doing this. I was like kind of wobbling because I'm trying to balance, I'm always looking at everything. It's like subconscious. And that's how you're balancing. You're kind of, you know, it's not just your inner ear because you're not moving, so you have to balance off of visuals. I have a friend who has a brain injury, and he can only balance visually. If he closes his eyes, he'll fall over because his inner ear is always spinning. So for him, visual matters. I don't think VR would be a good fit for him because that would totally mess him up. He'd have to sit down or lay down in order to use it. So what Google did was they reduced this field of view into the smaller area in the center. It leaves the sides open so your peripheral is still seeing this like anchored grid. That whole weird sensation completely goes away. It's pretty amazing. Next thing we want to try to avoid is motion sickness from moving. So there's a thing called teleport movement. Instead of walking to another position like you would in a game, when you're wearing a headset, you're standing in one position only, and you're moving in the game like you'd be playing a first-person shooter, but again, it's the whole environment. So now it feels like the floor is moving, you're being pulled on a rug, or you're slipping on ice, and your brain is like, whoa, what's going on here? Some people say it's fine. I think they're lying. Everybody's feeling sick a little bit from that because it's pretty unnerving. So what some people have come up with is a way that you can teleport to another position. Here's an example of that. You get a bit of an arc and then a dot as to where you're going to move to. And then when you let go, you appear there. Here's another version of that. So you kind of point out to a spot and then you jump to that spot. Yeah, it's not the best interface in the world, or the best interaction, but it gets rid of that motion sickness because you don't feel like you're sliding along. And if I put everybody in here in a game, had you just move forward normally, you'd all do this because your body can't handle that. It's trying to figure it out. In fact, when I first got my system, I found that if I pressed my legs up against the desk, it helped anchor me a little bit so that I didn't fall backwards because you can't really tell what's going on other than the pressure in your feet. This is a game called Robo Recall. This is pretty intense. It's a lot of action. Well, you're not running around. You're fighting robots. They come in. You can do like bullet time, like in the Matrix. You can catch bullets. You can throw them back. You can grab things, throw it apart, throw them back. And it's super intense the way the gameplay goes. So you'd say, you know what? I know not to run. I know I'm playing a game and I shouldn't physically run in my room because I'm just going to slam into the wall. But that game is so intense, I don't think you'd remember after a while. You'd get into it and I think you would start to step around. So what they've done is when this game came out of beta, they added in the teleport jumps. And it is a little clunky. I'm still not a complete fan of the system, but I am a fan of the fact that it doesn't make me sick playing it. So it's a trade-off for now until we figure out something better. This is what can happen. So this is a guy playing a climbing simulator. He's standing on the spot where he should be, and he tried to reach forward for something. Remember, it's virtual, it doesn't exist. And he didn't know he was leaning forward like that because he can't see the real world. He can only see what's in the headset. So that's what can happen. Now these sensors, when they pick up where I am in space, there is a safety thing that they've done where you kind of take your controller and you draw a box around what's safe. So I'd put the box back here so I don't walk into the speaker. You have to give yourself more room. This is too tight for that. But you kind of define your safe zone and you clear everything out, including the cat, because the cat won't know and you'll kick the cat across the room, because unless you add a sensor to the cat, now the cat's in the game or something. But when you define those boundaries, as you step closer, I'm about to step into the wall, a grid comes up in the middle of the game. So I could be standing in a field, and all of a sudden this grid comes up in front of me. I can still see the field. It's letting me know I'm about to hit that boundary, and I should step back. That would have helped this guy, knowing that there was some sort of boundary there, so he wouldn't hit anything. But he leaned forward, and there's nothing you can do there. And the same thing happens if you're playing billiards. So I've played a few of the billiards games. They are awesome. That's the coolest thing ever. But when you're playing those, you have to lean forward to take a shot sometimes. And, you know, it's a ghost table. It doesn't exist. So again, you lean forward and you lean on nothing. Now, if you're wearing an augmented reality headset and you could look at your kitchen table and turn that into a pool table and you could physically lean on your kitchen table and then you could take your shot, that would be pretty cool. That'd be safer. But this is dangerous. Remember, you're designing, as a designer, you're responsible for the interactions and for the safety and well-being of the person that's using your system. And this is a fail. So that's the different interface things that I've encountered and some of the different interactions. I think if you follow those, it will definitely help you with just making your interactions a little bit better and your experiences a little better. Because the idea is we don't want to turn people off. Oh, I tried VR in 1995. All I did was throw up. It was horrible. I had headaches for days. I'm never touching that again. Well, there goes a customer. So these things are out. They're really cool. But we have to make sure people are able to use them and not freak out about it. Now, we don't all know we're going to get motion sickness. That's something that's just going to happen along the way. But we as designers know that because we're testing things out. We might A/B test, we might bring in some users, or just give it to everybody in the room to try out, and you'll find that. So, future cool stuff going on. Real-life analog for a VR environment. So this one is a virtual cat simulator saver. I don't know why this cat is out here. I guess VR OSHA doesn't exist. But there's a cat hanging out on a platform off the side of a building. So what they've done is they've put a board an inch off the ground, padded floor, little VR cat right here, and you have to crawl out and get that cat. Now, again, like I said, when you're in the environment, your brain, it's so amazing and so fast how it maps to whatever you feel. If this podium was in the game and it's here, as soon as I touch it, it just like makes you really feel like you're there. So for this poor person, they're, they feel like they're on the side of a building. I don't think I could do that. That's not for me. Here's one that's really awesome. Anybody familiar with Rhett and Link on YouTube? These two guys have their channel, blah, 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 whatever. So they did a VR body swap, and what they did is they set up a mannequin, put a tie-dye shirt on, got the one guy, Link, put a tie-dye shirt on him. The mannequin had a camera facing down. He's wearing his VR headset. He's looking down. So they're both looking down towards their feet. They can see the shirt. And as they rubbed a live snake on the mannequin, they rubbed a rope on him. That's the mannequin. There's the rope on him. And he's completely freaked out. So I don't know if you call that cool. I think it's kind of fun. But what's neat about it is VR can be used for body swaps. So you can do this really cool level of empathy, walking in someone else's shoes, literally walking in their shoes. Or what I want to start working on is some projects where you take, say, disabled people with wheelchairs and other things like that, build an environment where an able person can sit in a chair. Now they're in a wheelchair and they have to learn how to navigate ramps and everything. I mean, we all know it. We know what that's like. But to truly experience that, I think, would be very empowering to have people start changing architecture and other designs. You could have somebody wearing a VR headset, all of a sudden you make them blind, navigate the street. You have your sensor so you can use it like a cane. How do you get to the bus? How do you do this? How do you do that? You can build all that in. You can change it to limited visibility or limited vision. So the empathy level there is great with body swaps and just turning on and off senses. This is a warehouse that's been mapped out for VR. So these are nice, I believe they're padded walls. They should be padded. And everybody's got their sensors on with their guns and their helmets and everything. This was a one-to-one environment. So, like I said before, if this podium is in the game, in real life there needs to be a box here that I can feel. This requires a high level of trust on whoever developed it to make sure that they're not even a quarter inch off, because if you come barreling past that column, that's going to suck. So there what they've done is they built out the whole environment. Now in the game they're in a spaceship or doing whatever. This is going to be the future of theme parks, virtual theme parks. You may not have to go to Six Flags or wherever. You can take all the old Kmarts that are abandoned and turn them into places. There's plenty of those. I've been wanting to do that in Portsmouth. So what they're doing, there's a company out of Utah that's doing this. They take these and they're mapping the space. They can load it up as a dungeon or a spaceship or whatever, and people can go in and play games. They've even gone as far as putting heat lamps up on the wall, and in the game there's a torch, and as you physically walk by you feel heat, but you see a torch flickering. And there could be a platform that you step on, you press a button, it's an elevator, the platform vibrates, but it doesn't actually move. And people think they've gone up 20 feet and they're kind of like shouting down, is it okay to step off, and stuff like that, because they don't know. It's going to be pretty cool. If you want to try something like this, Madame Tussauds in New York City has the Ghostbusters VR experience, and you can go check it out. I haven't done it yet, but when I get down there, I'm definitely doing that. Walking in place. So here's a cool idea. Concave surface with slippery things on the shoes with sensors. You just stay in place and you can run and turn and jump and do everything. Give you one bit of advice. Video games are not in human scale. If you try to run across the World of Warcraft map, I think you have to do 15 miles an hour for like 2 hours in order to actually get across. So it's cool, but it's also tiring. But that leads into a whole other thing about losing weight by using VR, which is something that I want to try and document as well, like heart rate and all of that. So this is pretty cool. This allows you to work in a safe environment. You're not going to fall over. You can turn, you can play your games, you can do everything. And hopefully it'll prevent stuff like this. The internet's gold for this. And finally, the last thing is predictive motion. This is something Disney's been working on. So they have they built out a way with a ball that has mapping points on it that they can throw it to a person, and the person can catch it. This guy's actually pretty good that he can catch that just from VR alone. What they've done is they've added sensors so there's trajectory projection. So they can determine where that ball is going to move to and put a little bit of an arc line so you know where to move your hand to. I don't have controls on here, so I'm sorry, I just have to let it play for a moment. What they eventually do is they get rid of the arc line and they just put the target in space. Here we go, I think this is it. So when they throw it, they kind of show the little point as to where it's going. And people's reaction time improved because they could move their hand to that virtual space and then catch the ball, and it actually improved everything. So that's pretty cool. There's some neat stuff going on. So that's it for what I have to talk about for WebVR, for everything else. One last thing I wanted to talk about was just a quick 2 slides on WebVR. Anybody remember VRML? Virtual reality markup language? Woo-hoo. Back in the day, back in like 93, 94. Dating myself on that one. WebVR is not VRML. VRML is gone. WebVR is a JavaScript API that supports VR devices. What it can do is detect a VR device, query its capabilities, does it have touch controllers and other things, track position, so it can use all of the infrared capabilities, and display everything at a functional frame rate. So it's not going to be 4 frames a second. It's going to be 30, 60, 90 frames a second. Video game level frame rates. For more information on that, here are some of the slides, or some of the places to go. aframe.io is really amazing. And what they've done, I don't think this is going to work in here anyway. It's a full VR environment that you're mapping. You're bringing stuff in from Unity or any Blender or any of the 3D modeling systems. You can bring in all of those elements, display them in a web page, build out panoramic players, panoramic video players, and full games. Probably not like the Robo Recall one, but some lesser games to that extent. But that's all built out in HTML, which I think is pretty amazing. And I wasn't able to get it running on here. You have to use nightly builds of Chromium and Firefox in order to get it to work. So it's still in flux right now, but I think it's a good time to start learning this. So once it comes out in prime time in the primary browser, you'll be able to start integrating different VR capabilities into your applications. IKEA and Wayfarer and a few others are doing that. They're allowing you to look at 3D models, working with augmented reality, which I think WebVR will probably be able to handle that as well, because you'll be looking at video and overlays. So you can have like put a couch on the floor and a poster on the wall or a painting or whatever, or change that to a mirror and change the color of the room. And that's it for all of this. This is another picture of me. I like to brag. Yeah, Center Ice down in Boston. I thought that was fun. I was shooting for the Hockey East finals, so I got to go out there. This was a test shot, and then in front of like thousands of fans, I had to do a gigapixel image of the crowd and get everybody kind of charged up, which was cool. I don't know how we're doing on time. Are we good? Yep. All right, awesome. Thank you.